What if a number is not a perfect square? How would we ever know that it's not a perfect square? And what can we say about its square root? Let's suppose that we want to know about, for example, the square root of 34. Looking at the multiplication table, well, we don't see 34 along the diagonal. More than that, we see that 5 squared is 25, and 6 squared is 36. Of course, the larger the number, the larger its square is going to be. So if 34 has a square root, it's going to have to be somewhere between 5 and 6. Now, there are no whole numbers between 5 and 6. Right? There just aren't. If we have 5 things and then we get one more, we have 6. Therefore, we can conclude that the square root of 34 is not a whole number, and thus 34 is not a perfect square. But we know something about its square root. We know what two consecutive whole numbers the square root of 34 is between. And we can do this with any number that's not a perfect square. For any number that is not a perfect square, we can find two consecutive, that means just one after the other, like 5 and 6, whole numbers that its square root is in between. How? By finding two perfect squares that our original whole number is between. So this is pretty straightforward. Say we want to find two consecutive whole numbers that the square root of 45 is between. Consulting our multiplication table, we see 6 squared is 36, and 7 squared is 49. 45 is between 36 and 49, so root 45 is between 6 and 7. I'm going to have you try one of these. Find two consecutive whole numbers that the square root of 7 is between. Pause the video and try this now. Alright, well, looking at our multiplication table, we see 4 and 9 are consecutive perfect squares that 7 is between. And so, since 2 squared is 4, and 3 squared is 9, root 7 is between 2 and 3.